Hi. So I didn't even notice, but I made an error in well, not last, it's deleted, but in the video where I explained the idea of a deep neural network, which is, yeah, which sucks. But so we have our inputs, and we have our uh, layers, right? So as opposed to a shallow neural network, um, let me keep going and I'll explain on the way. Right? So as opposed to a shallow neural network where this is our Z1, right? And Z1 has the parameters weight 1 and bias 1. And Z1 is calculated by W1 transpose, W1 transpose X. So W1 transpose times X plus B1, right? So now that goes in here. I'm not gonna draw every single line. I just want you to get the idea of it, right? Oh, okay, that is horrible. All right, and that goes here, and that goes there, and that goes there, and A1 is calculated, right? Where A1 is equal to some activation function applied to Z1, right? And then that goes here into right there, right? I'm not gonna draw. Actually, yes, I am. So A1 goes into here, and that's Z2, right? And Z2 is equal to, oh, sorry, it has the parameters W2, right? Weight 2, bias 2, and Z2 is calculated by doing W2 by Z1 plus B2. Or, I'm sorry, I have no idea why I said Z2, A1, right? So W2 times A1 plus bias 2. And A2 is obviously, again, just some activation function applied to uh, Z2. And just to show this, right, this is A2 right here. So that goes here, right? And now, instead of just stopping here with a deep neural network, we're gonna go further, right? We're gonna go boom, 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 right? And we're gonna keep doing this. And why does that look like that looks like a toast bread? Okay. So boom, boom, right? Uh, let's say this is Z3, and I really hope you can kind of tell what's this should be red. Sorry if this is confusing, right? That should be red because A1 is going into these layers. And Z3, I hope you can already tell what's going to happen, but I'll write it anyways. Z3 is going to have the parameters weight 3 and bias 3, and Z3, and when I say Z3, I mean this layer, right? So you can say this is your third layer, right? Second layer, first layer, and so on. And Z3 is obviously calculated by W3 A2 plus bias 3. And A3 is, again, some activation function applied to Z3. And we just do this over and over again, right? So maybe Z50 or something, 50 layers, right, for instance, until we finally get to our output layer. So let's just say, for example, the sigmoid of ZL, right? Because Z, we don't know what Z is. It could be 50, whatever. So let's say sigmoid. We're taking the sigmoid of ZL, which produces y hat. So, and I hope you can see what the forward propagation is gonna be like, right? Now, the only difference is instead of just feeding this into a single output layer, where this wouldn't be 4, right? This would just be 1 in a shallow neural network, and we just calculate weight 2, right? Instead, we take the activation function and we feed it right into another layer with a amount of neurons. So W should be like, for instance, let's say there's 5 neurons in here, right? This is gonna be a 5 by, well, not really, there's 4 neurons, right? And so it's gonna be a 4 by 4, right? So 4 by 4, right? 4 by 4. And I'll cover the matrices in another video. Yeah. No, actually, no, I'll just do it right here. So our weight, we can say our weight is gonna be the current layer, right? So current layer by the last layer matrix, right? And I hope that makes sense. So like Z3, so this the third blah, blah. So W3, right? And I should say WL, right? Whatever. Right now I'll just leave it as W. So W3 is gonna be W just, so that's gonna, W3 is gonna be a W3 by W3 minus 1, right? 3 minus 1 matrix, right? And our biases are just gonna be that layer, and that's how we compute our matrices here. So again, I want you to know the only difference is we just continue on adding more Z3s, adding more Z's, more A's, multiple times. And instead of just feeding this into here, we're just going over and over again instead of a shallow neural network. I probably went around spirals explaining